Known the world over as the stealth fighter, the Lockheed F-117 Nighthawk became one of the most instantly recognizable warplanes of all time. Its extraordinary shape was driven by one goal: to achieve the lowest possible radar signature, low enough to allow it to disappear from radar screens. It was the first aircraft to achieve this holy grail of military air power, to operate undetected in the face of hostile defenses. It was developed in a cloak of secrecy that rivaled that of World War II's atomic bomb project. So successful was the security surrounding the program that the F-117 was flying for 7 years without anyone gaining a notion of what it looked like, apart from those few who were directly involved or the handful with the need to know. When it eventually emerged from the black world, it astonished the public with its otherworldly looks and sci-fi capabilities. Its reputation and fame reached new heights as it became the undisputed star of the Desert Storm aerial campaign over Iraq in 1991. As the 1990s progressed, a changing world and new technologies began to rub the shine off the F-117, and the shooting down of one over Serbia in 1999 finally brought the aircraft's glamour years to an end. Nevertheless, it still had an important part to play over Baghdad in 2003, although Operation Iraqi Freedom was almost certainly to be the aircraft's swan song. After 25 years of being at the tip of the American spear, the Black Jet Force is being slowly mothballed, prematurely in the eyes of many. While its shape was set by the need for stealth and based on the general concept of the Have Blue, the F-117's size was driven by the requirement to carry a pair of 2,000-pound class bombs and sufficient fuel for mission requirements. The result was an aircraft in the general size class of the F-15 and F-22. Several parts from the Eagle were borrowed to save costs in the design and production process. Empty weight of the F-117 is around the same as the F-15 and F-22, but its maximum takeoff weight is 2 tons less, a function of the compromised aerodynamics and non-afterburning engines. The F-117 is marginally supersonic in a shallow dive, with a top level speed of around Mach 0.9. Combat radius is around 600 nautical miles. In the early days, the F-117 was considered to be somewhat tricky to fly, but such misconceptions were laid to rest for much of its career. Generally, the aircraft handles much like a Delta. It flies nose up at low speed and bleeds energy rapidly in a turn. It can be surprisingly maneuverable, although it needs an experienced hand at the controls to avoid the pitfalls of rapid energy loss. It is stable on the landing approach, although its low thrust-to-weight ratio provides little margin for emergency situations. The landing speed is quite high at 150 knots. The lack of thrust also means that the takeoff run is quite long, meaning that it can only safely use full-length runways. There was no two-seat trainer produced, and all F-117 pilots, or bandits, progressed straight from the simulator to a solo flight. As all potential bandits were already experienced aviators with at least 500 hours flight time in military aircraft, this has not been a problem during the type's long career. Most flight training involves the student being watched by an experienced instructor, flying a T-38 Talon trainer alongside. With an overarching need to maintain the F-117's stealthy properties, every other element of the aircraft was by necessity a compromise, and that includes the weapons. For a start, there was no possibility to carry any weapons externally, so they had to be carried in internal bays. The aircraft has two bays in the underside of the fuselage. The bays are situated side by side, squeezed in between the engines. Each bay has a single door with sawtooth sections on the leading and trailing edges. Inside each bay is a trapeze which mounts the weapons. The trapeze can swing down and forward so that the weapon is in the airflow, but this seriously affects the aircraft's stealthiness. Early tests were made dropping weapons with the trapeze down, but subsequent drops of free-fall weapons have been made with the trapeze up. The trapeze does, however, make bomb loading much easier. It is dropped down, allowing the bomb to be installed outside the cramped confines of the bay. The trapeze is then retracted into the bay with the bomb attached. To minimize the disruption to the aircraft's low observable characteristics, the bay door is opened quickly, the bomb is dropped, and the bay door then snaps shut to restore the so-called LO bubble. Small airflow baffles deploy down at the front of each bay when the door is opened to ensure a clean separation of the weapon. The trapeze theoretically allows the F-117 to fire missiles, and the AGM-65 Maverick, AIM-9 Sidewinder and AGM-88 Harm have been associated with the type. As far as is known, however, the F-117 has only ever used gravity weapons. What the newspapers christened the stealth fighter has never been anything other than a bomber. Surprisingly perhaps, the F-117 was never wired for nuclear weapons. It therefore carries a range of conventional bombs that can fit in the confines of its weapons bay. These include the Mark 80 series of unguided bombs, although their use was largely restricted to initial weapons training, as free-fall weapons make no use of the F-117's precision guidance system. The baseline weapon for the F-117 is the Paveway 2 laser-guided bomb. This mates a laser guidance section, complete with control fins, to the nose of a Mark 80 series warhead, with the tail section containing pop-out wings to extend the bomb's range. The warhead can theoretically be the Mark 82 of 500 pounds, Mark 83 of 1,000 pounds, or the 2,000-pound Mark 84. In practice, only the latter has been used, the resulting weapon being known as the GBU-10. An alternative is the GBU-10I, which mates Paveway 2 guidance with a BLU-109 Have-Void warhead. This has thick steel casing and a tail-mounted fuse. The bomb is designed to penetrate through concrete before exploding for use against bunkers, aircraft shelters, and other hardened targets. The Paveway 2 system, though relatively cheap, has limited range potential and a simple guidance system that allows only a near ballistic approach profile. The much more sophisticated Paveway 3 was developed to provide a flat approach trajectory, while its much larger wings and more subtle guidance gave it much greater range. It was an obvious candidate for the F-117. However, the large wings of the standard Paveway 3 weapon were too large for the weapons bay, so a hybrid bomb was developed, using the new guidance system but with the old wings of the Paveway 2. The result was the GBU-27, unique to the F-117. Like the GBU-10, it came in a standard Mark 84 warhead version and another with the BLU-109 penetration warhead. The GBU-27 did not have the range of other Paveway 3 versions, but that was of less significance to the F-117, which could operate much closer to targets than non-stealthy aircraft. The new guidance system greatly enhanced its lethality against hardened targets, allowing the bomb to be flown through the front door rather than through the roof, which was usually better protected. GBU-10s and 27s remained the standard weapons until around the year 2000, when the EGBU-27 was introduced. This added GPS guidance to the existing laser package, allowing the bomb to be dropped with great accuracy, even when other factors precluded the use of the laser system. It also greatly decreased the chances of collateral damage caused when laser lock was lost when the bomb was in flight. The last weapon to be cleared for the F-117 was the GBU-31 JDAM, a GPS-guided 2,000-pound weapon. A much cheaper weapon than the GBU and EGBU-27, it is only marginally less accurate. When the F-117 community was notified of its impending retirement, the test team was about to start work on integrating the wind-corrected munitions dispenser and the GBU-38 500-pound JDAM. The team was also studying the GBU-39 small-diameter bomb, of which up to 8 could be carried. According to the basic principles of stealth, the F-117 could not have a radar, as any electromagnetic emissions would have betrayed the presence of the aircraft. Today, the development of low probability of intercept radars has overcome this hurdle, but at the time of the F-117's development, such technology was still a dream. Operating without a radar and at long distances from reliable ground beacons implied that the F-117 needed a highly accurate organic navigation system. This need was further exacerbated by the way the targeting system worked, requiring the aircraft to be accurately positioned for positive target acquisition. The most accurate navigation system available was the Honeywell SPN GEANS, an inertial system developed for the B-52. This could handle complex route profiles and showed very low drift figures, but once the F-117 was airborne, it was almost totally reliant on the system to put it in the right spot for targeting. Of course, that correct spot was determined in the first place by accurate intelligence information, and it was unlikely that F-117 sorties would be launched without it. However, if the intelligence was correct, and the inertial system remained within drift limits, the system automatically cued the infrared system to the computed target location. The Texas Instruments Infrared Acquisition and Designation System, or IRADS, was an off-the-shelf system adapted to the peculiar needs of the F-117. Normally, such a system would be a single sensor turret, mounted so as to see over the lower hemisphere from fully forward to back under the aircraft's tail. Such a system could not be installed in the F-117 without destroying the stealthiness, so a twin-turret installation was devised. The upper turret, known as the forward-looking infrared, was mounted just ahead of the windscreen. To give it sufficient field of view, the F-117's nose profile had to be made steeper than was desirable from a purely stealth point of view. Underneath the aircraft was the downward-looking infrared. The fields of view of the turrets overlapped, so that locked-on targets could be handed over from one to the other seamlessly. Both turrets were mounted behind mesh screens that allowed the sensors to see through, but appeared as a flat surface to a radar. Both turrets were interchangeable. However, they were mounted with one upright and the other upside down, so that the imagery from one had to be electronically inverted by the system so that it appeared the same. The turrets housed infrared sensors with wide-angle view for initial target acquisition and a narrow field of view for detailed aiming. Each turret had a laser designator. Although it was normally the lower laser that was used, the F-117 did have dive bombing capability, for which the forward laser could have been useful for range finding. As the F-117 neared its target, The nav system cued the forward turret to look at the theoretical target position in wide-angle mode. The imagery was displayed in the cockpit. The pilot checked the initial position, making corrections as necessary by moving a cursor on the screen. With the general target acquired, the system was locked on. As the target was approached, and as it slid beneath the nose of the aircraft, the system swapped from forward turret imagery to that from the downward turret. Although the system used contrast tracking to remain locked on to the initial point, the pilot refined the aim point continually, switching to narrow field of view for very accurate targeting. The system allowed individual doors, windows, air vents, or chimneys to be targeted. Following consent from the pilot, the weapon system automatically released the bomb at the optimum point, and the laser was fired to guide the bomb. The downward turret remained locked on throughout and stayed locked on after the explosion to monitor the effects of the strike. The imagery was recorded, allowing instant battle damage assessment after the aircraft returned to base. The pilot of the F-117 sits under a heavily framed cockpit. The small windows give a limited view of the outside world, just adequate to perform the basic flying tasks, but little else. The small windows are treated so that they appear to radars as flat metal surfaces, just like the rest of the aircraft. The pilot sits on a McDonnell Douglas ACES II ejection seat that gives zero speed, zero altitude escape capability. The seat fires after the heavy canopy has been blown off fractions of a second earlier in the escape sequence. Design of the F-117 cockpit borrowed heavily from that of the F-18 Hornet, and several of the components were the same, including the monochrome multifunction displays. At the top of the instrument panel is a head-up display for basic flight and navigation information. Below this is an upfront control panel for data entry. Dominating the center of the cockpit is a large screen. In early aircraft, this was used to display the infrared imagery from the IRADs, but in OSIP-2 aircraft, it is a moving map display. Either side are two multifunction displays, which can be used for a variety of data displays. The original monochrome units have given way to color MFDs, one of which is used in the OSIP-2 aircraft to display IRAD's imagery, since the dedicated screen was replaced. The MFDs are used in flight to present attitude and horizontal situation information. Below and outboard of the right-hand MFD are the primary engine and fuel controls, below which is a warning panel. The right side console has a small screen and keyboard for the navigation and communication systems. Controls for the IRADs and environmental system. And switches to retract and extend the communications antennas. The left side console mounts the main aircraft system controls and throttles. In the left-hand side of the main panel are controls for the brakes and undercarriage, above which are backup flight instruments such as clock, altimeter, horizontal situation indicator, and attitude indicator. The panel just below the left-hand MFD mounts the master arm switch and bomb bay door controls. Buried within the F-117's faceted structure are a pair of General Electric F-404 F1D2 turbofans. Derived from the F-404 used in the Hornet, these engines offer good fuel economy and reliability. They can be accessed and removed through large doors under the fuselage. Air is fed to the engines through polygonal intakes. To stop radar energy getting into the intake duct, they are covered by a grille. The gaps in the mesh are much smaller than the wavelength of a detection radar, so that the grille acts as a flat surface. At low speed, the main intakes are augmented by auxiliary doors that open on top of the intake trunk to admit more air. As well as keeping radar returns to a minimum by faceting and the extensive use of radar-absorbent material, the F-117's designers also looked at the aircraft's heat emissions, as this can be a major source of detection. Exhaust from the hot core of the engine is mixed with fan bypass air and then passed through wide slit-like nozzles. The heat from the engines dissipates into the airstream much more rapidly than with a conventional circular nozzle. Measuring around 100 millimeters deep and 1.5 meters wide, the nozzles incorporate an extended lower lip to further hide the primary heat source from sensors below. The nozzles incorporate ceramic heat-resistant tiles, similar to those which clad the space shuttle. Fuel is crammed into the vacant fuselage space forward and aft of the weapons bay and in the two-spar wing structure. For ferrying, the F-117 can carry auxiliary tanks in the weapons bay. The aircraft is fitted with a refueling receptacle on the spine. This normally sits flush with the fuselage, but rotates for use to reveal the receptacle. The prominent pimple at the apex of the fuselage houses a rear-facing floodlight that illuminates the receptacle, so aiding the boom operator during night refuelings. To preserve the low observable bubble, the designers kept the number of breaks in the outer skin of the aircraft to a minimum. Where they were necessary, the edges were given a sawtooth pattern that traps and dissipates radar energy. The undercarriage retracts forward and is based on that of the F-15 Eagle. Under the rear fuselage is an arrestor hook for runway emergencies. It is covered by an explosively jettisoned cover. Between the twin fins is a compartment for a brake shoe. This was widely used in the early days, but since the adoption of carbon-carbon wheel brakes is now used mainly during crosswind landings. Designing an aircraft that is both stealthy and stable was considered virtually impossible, so a fly-by-wire system was adopted to keep the aircraft in the air. However, an FBW system needs accurate air data, posing something of a problem for the Skunk Works engineers. The answer was to provide 4 air data probes in the nose, each carefully faceted to avoid radar reflections, and each heated to prevent icing. Fed with information from these probes, the flight control computer commands the operations of 6 movable surfaces. The twin fins mount large ruddervators that work in unison for roll control and in opposition for pitch control. On the trailing edge of the wing are 4 sections of elevons that work together for pitch control and in opposition for roll control. The gaps between the control surfaces are obviously a major radar hotspot, and so have been fashioned into unusual notches that dissipate radar energy. Another unusual feature of the F-117 is the use of retractable antennas for key communication systems. Typical blade antennas reflect a sizable amount of energy but are necessary for certain communications. Making them retractable provides the capability without compromising stealth. There are times, of course, when stealth is not a good thing. In peacetime training, the F-117 needs to be seen by air traffic controllers on their radars. Prominent radar reflectors are often attached to the sides of the intake trunks to allow a radar return. In its formative years, the F-117 community operated under a veil of total secrecy. Test flights were conducted from Groom Lake, a secret base buried deep within the vast Nellis weapons range. The tests were undertaken by a joint Lockheed Air Force team that became known as the Baja Scorpions. The first operational unit was the 44th 50th Tactical Group, the Goatsuckers, which began operations from Groom Lake. This base was ideal for testing, but not so good for an operational unit. From 1979, another secret base was established at the abandoned Tonopah Test Range airfield, also within the Nellis Range complex. The Goatsuckers moved to Tonopah from May 1982 and set about the task of creating an operational force. Personnel lived in Las Vegas and were flown into Tonopah by a civilian contractor airline for the week's work. All training was conducted by night to satisfy security concerns. As well as a growing number of F-117s, the 44th 50th also had some A-7 Corsairs assigned for chase duties and daytime proficiency flying. In October 1983, the 1st Squadron was declared combat ready. That month it was considered for combat missions in Grenada and Lebanon, but it was felt that the force was not yet sufficiently prepared. In April 1986, F-117s were placed on alert to attack Libya, but were stood down at the last moment as their use was considered an unnecessary security risk. The nocturnal flying and strained lifestyle inevitably took its toll, and there were a number of accidents and incidents. These led to increasing calls for the F-117 to be brought out of the black world so that pilots could train by day and enjoy a more normal way of life. The aircraft was finally revealed to the public in November 1988 with one fuzzy photo, although there was little in the way of hard fact released. In October 1989, the 44th 50th was redesignated as the 37th Tactical Fighter Wing, and 2 months later the F-117 went into battle for the first time during Operation Just Cause, the US invasion of Panama. 6 F-117s were dispatched from Tonopah, 4 to be used in a special operation to snatch Panamanian leader Manuel Noriega. This was called off at the last minute, but the other 2 F-117s continued to their target. It was a field outside of barracks, and their bombs were intended to stun the sleeping soldiers to facilitate an American assault. The bombs were dropped with mixed success, but the Panamanians already knew of the planned assault and had already left the barracks. This inauspicious start to the Nighthawk's combat career was swiftly forgotten when Operation Desert Storm got underway on the night of the 16th of January, 1991. A large portion of the fleet, 42 aircraft, was deployed to Khamis Mushat in Saudi Arabia, nicknamed Tonopah East by the troops. An F-117 dropped the first bomb of the war, knocking out the Central Air Defense Command Center of the Baghdad area. Over the course of the next 42 nights, another 1,270 missions were flown. F-117s concentrated on the Baghdad area. After the war, the F-117 community was brought further out of its secrecy by moving the force to Holloman Air Force Base in New Mexico in mid-1992. The wing became the 49th Fighter Wing. Small numbers of F-117s were deployed occasionally to the Gulf Theater, and in January 1993 dropped bombs again in a punitive raid on Iraqi air defense sites. In 1992, the Baja Scorpions test team moved to Palmdale, also home to the Skunk Works. Here it became the 410th Flight Test Squadron, continuing to fly on developmental test duties until news of the F-117's retirement. Another trials unit, the Dragon test team, was formed at Tonopah for operational test duties, also later moving to Holloman. When NATO launched Operation Allied Force against Serbia in 1999, F-117s were again to the fore, employed mainly against high-value targets in the Belgrade area. On the fourth night of the war, the unthinkable happened. An F-117 was successfully targeted by a surface-to-air missile and was shot down over Serbia. The pilot ejected successfully and was retrieved by a combat search and rescue team. F-117s were instrumental in the shock and awe air campaign against Iraq in 2003. The first aerial mission of the war was an attempted decapitation strike against the Iraqi leadership flown by a pair of F-117s operating from Al Udeid in Qatar. Only 12 F-117s were deployed for Operation Iraqi Freedom, but they performed surgical strikes against numerous high-value targets, mostly using the EGB-U-27 bomb. This was most likely the last major action for the F-117. In late 2005, the US Air Force announced its plans to retire the F-117 by the end of 2008. It cited increased operating costs and the need to reduce the number of types in the fleet as reasons. The first aircraft began entering storage at Tonopah in 2006. Replacing the F-117 is the F-22 Raptor. Although the new aircraft is stealthy and high-performing, some capability will be lost as it lacks the ability to undertake pinpoint attacks with laser-guided bombs. The F-117 was designed with one purpose in mind: to attack the enemy's most valuable targets, no matter how well they are defended. Such targets can range from key nodes in the air defense network and critical command and control centers to infrastructure targets such as power stations and bridges. Stealth aircraft are crucial to what are termed first-day missions, the initial strikes of an air campaign designed to cripple the enemy's air defenses. Many of these targets are in urban areas, requiring pinpoint precision. Many are buried underground, requiring penetration weapons to achieve their destruction. And most are in heavily defended areas. In order to get close enough to the target to deliver the knockout punch, the F-117 has to be able to survive, requiring careful planning and, of course, stealth. Most operational missions require careful preparation, but those for stealthy aircraft are even more involved. Before the mission, technicians prepare the aircraft by ensuring that it fully meets low observability requirements. The radar absorbent material that covers the F-117 is rigorously checked and replaced if damaged. The material can be applied as either sheets or as a spray. Any unnecessary antennas or peacetime equipment are removed. Weapons are loaded into the fuselage bays. For most missions, that means a pair of laser-guided bombs in the 2,000-pound class. Meanwhile, the mission planners are drawing up the optimum routing for the mission. Most F-117 missions require the aircraft to spend a long time in denied airspace, while the planners also want to achieve maximum surprise. Mission planning is performed using a system nicknamed Elvira, after the Mistress of the Dark TV character. The system has all known surface-to-air threats stored, and then plots a route that takes into account the F-117's own radar signature characteristics. From certain angles, the F-117 is more visible to radars than others, so the route is plotted so that these angles are never presented to ground defenses. The complex route is then loaded via cartridge into the aircraft's navigation system. To maximize their stealthiness, F-117s operate almost exclusively at night. In some scenarios, their actions may be coordinated with other strike aircraft, or they can operate alone. Prior to entering hostile airspace, it is customary for the F-117s to top up their tanks. Depending on their route to the target, they may be gone some time, and there may be a need to re-attack. In a coordinated attack with other F-117s, the aircraft may all enter hostile airspace through a common gate, perhaps one that has been created by other aircraft. Alternatively, they fly through a series of jump-off points. The aircraft will fan out into enemy territory to approach their targets, or fly a similar route in trail, using time separation to keep them deconflicted. If multiple F-117s are attacking the same target location, then they may approach from different directions. Accurate timing is crucial to the overall surprise effect of the mission. The standard profile is to attack from straight and level flight at high altitude. At this point, the pilot is relying on the aircraft's stealth properties to keep the F-117 invisible to the defenses below. If the aircraft has not been detected during its ingress, it will not be expected either. For the most accurate attacks, laser-guided bombs are used. With the target acquired and locked on by the IRAD system, the bomb is released. The optimum moment for bomb release is computed by the aircraft's weapon system, just as with an unguided bomb. Even without laser guidance, a properly aimed bomb will hit quite close to the target by itself. However, for the required pinpoint precision, the bomb needs guidance. The aim of the initial ballistic release is to place the bomb in a theoretical basket. Any bomb dropped into that basket will be within the parameters required for the laser guidance to work. As the bomb enters the basket, the laser designator is fired and the bomb fine-tunes its trajectory, continually receiving guidance commands until it hits the desired aim point. Attacking with Paveway 3 bombs is a little more complex, as they have the ability to perform different approach profiles. For instance, they can be said to arrive at the target from a horizontal aspect or vertically. For attacks against buried targets such as bunkers with several floor layers, multiple bombs can be dropped on the same aim point with a short time delay between them. The explosion of the first bomb creates a hole through which the following bomb can fly, allowing it to explode deeper inside the target. Many factors can affect the performance of the F-117's laser and acquisition system, such as cloud cover or dust. In some instances, the pilot has to call off the attack before release, and in others, laser lock can be lost while the bomb is in flight, resulting in it falling ballistically. In some scenarios, the F-117 can set up a re-attack in the hope that the conditions improve for a second attempt. The aircraft's stealthy attributes allow it this luxury that few other aircraft can afford. Recently, the F-117 has adopted a new class of weapon that has overcome this problem. The enhanced Paveway bomb retains the laser system but also adds a GPS receiver. In the event that laser lock is lost, the GPS system takes over, guiding the bomb to a near-precision hit. With the bombs gone, the F-117 returns to base, carefully picking its way through the radars that are still working. Often, the F-117 will have been the first wave of a major airstrike, so its return routing will have to be deconflicted from the flow of other strike aircraft heading into enemy airspace. After landing back at base, the results of the strike are assessed to ensure that the objective has indeed been achieved. The aircraft is turned over to the maintenance troops, who have a day to prepare it for the following night's mission. The concept of making aircraft less visible to radar had been around for some time before the F-117 appeared. Leading the effort was the Lockheed Company, in particular its Advanced Development Projects Office, better known as the Skunk Works. The Skunk Works had successfully developed and fielded radar reduction measures on the U-2, while the SR-71 had various radar reduction measures incorporated into its design from the outset. However, the Blackbird was still visible to radars, albeit with reduced signature. To make an aircraft that could remain unseen would require a whole new set of technologies. The history of the science which eventually produced the F-117 goes back to the 19th century. Scottish physicist James Clerk Maxwell derived a set of formulae that would predict the manner in which electromagnetic radiation would scatter when reflected from a given geometric shape. This work was refined by the German scientist Arnold Johannes Sommerfeld, and again in the 1960s by Dr. Pyotr Ufimtsev, chief scientist of the Moscow Institute of Radio Engineering. Ufimtsev's work was collected and translated as part of the US Air Force's ongoing monitoring of foreign technology developments, and so was available to the Skunk Works engineers. The earlier work had concentrated on simple two-dimensional shapes. Elements in the Skunk Works deduced that by reducing a three-dimensional shape to a series of constituent two-dimensional panels, the overall radar reflection behavior of a 3D shape could be predicted. The concept of faceting was born. Around this time, in 1974, the Defense Advanced Research Projects Agency had issued a low-security study program to investigate means of reducing radar cross-section. Lockheed had not initially been invited to participate, but when the Skunk Works heard of the program, its new boss, Ben Rich, presented the hitherto secret SR-71 work and was allowed to join the program. In the Skunk Works, a computer program known as Echo 1 was devised. This could accurately determine the nature of radar reflections from a faceted shape. In turn, it allowed the design of shapes that could form the basis of a stealthy aircraft. The first result was a shape nicknamed the Hopeless Diamond. A model was built in mid-1975 and pole-mounted for tests against a real radar. The results were extremely promising. Radar energy is typically reflected from surfaces and from edges. The basic concept of faceting was to always reflect radar energy away from the radar receiver by carefully aligning the surfaces. Restricting the number of angles along which edges were aligned vastly reduced the number of radar spikes that would eventually emanate from any shape. Careful mission planning could eliminate the traces of these spikes, while any radar hotspots on the aircraft could be treated with detailed shaping and radar-absorbent material. Results from the Hopeless Diamond pole model and its Northrop competitor were spectacular and led to further development in the form of a flyable aircraft designated XST. In April 1976, Lockheed was declared the winner and began the construction of 2 demonstrators. Having been built at Burbank, the first of the Lockheed XSTs was flown at the secret Groom Lake base on the 1st of December 1977 with Bill Park at the controls. By this time, the program had been christened Have Blue and had been designated top secret. The Have Blue was a derivative of the Hopeless Diamond design, and its construction included parts borrowed from several other aircraft. It was extremely unstable and needed a fly-by-wire system to keep it in the air. The first aircraft was used as an aerodynamic trials platform and was lost in May 1978 after 36 flights. The second aircraft was used for radar cross-section tests and first flew on the 20th of July 1978. It was lost in early 1980. Despite the losses, the Have Blue had showed sufficient promise for a full-scale development contract to be awarded in November 1978 under the codename Senior Trend. The contract covered 5 prototypes of a combat aircraft plus 15 production aircraft. The Skunk Works worked quickly on scaling up the basic Have Blue concept. On the 18th of June 1981, Hal Farley undertook the first flight of the Senior Trend from Groom Lake in Ship 780. An immediate result of early flight tests was the enlargement of the fins. By early 1982, the 5 FSD prototypes were flying from Groom Lake and undertaking a range of tests. They were unofficially referred to as YF-117s, the seemingly out-of-sequence designation having apparently been chosen to fit in with captured Soviet types that were secretly flown from Groom Lake under the designations between F-112 and F-116. 60 production F-117s were built at Burbank, although official figures show only 59. This is because the very first production aircraft crashed at Groom Lake during its first takeoff on the 20th of April 1982, before it had been assigned a US Air Force serial. The crash was traced to wrongly connected flight controls. Because of its unusual shape, the F-117 was unorthodox in its construction. The entire fuselage carapace was built as a single skeleton structure that housed the engines, weapon bays, cockpit, and fuel tanks. To this central structure was attached the wings, the nose section, and the fins. The fins were canted outwards and were positioned so as to shield the engine exhausts from infrared sensors that might be carried by fighters. Every external section of the aircraft is a flat surface, including the wings, which do not have a traditional aerofoil section. The underside, the part which faces ground-based radars, was made as flat as possible. The whole program was undertaken in extreme secrecy. Disassembled aircraft were flown by air from Burbank in C-5 Galaxies. They were covered in a shroud for transportation, with wooden structures placed over the airframe to hide its true shape. They were air freighted to Groom Lake in the early days for reassembly and first flight, and to Tonopah later in the program. There were several proposals for F-117 variants, such as the AF-117X for the US Navy, which had conventional tailplanes, reduced sweep folding wings, and a more extensively glazed canopy. Along with other proposals such as re-engining, it was not proceeded with. Instead, the F-117A fleet underwent a series of upgrades and modifications that enhanced its capabilities. Major elements were conducted under the Operational Capabilities Improvement Program, or OCIP. OCIP-1 replaced the original 3-mission computers with a single AP-102 system based on that used in the Space Shuttle. OCIP-2 introduced a new moving map display in the cockpit, as well as an auto-throttle that greatly enhanced the aircraft's ability to accurately meet waypoint times. OCIP-3 replaced the original inertial system with a ring laser gyro and later incorporated GPS navigation. In the early 1990s, a new IRAD system was installed. There were also structural upgrades in the mid-1980s, such as a new composite fin and new bomb bay doors that allowed the delivery of 2 bombs simultaneously. Brief thought was given to reopening the production line following the F-117 success in the 1991 Gulf War, but led to nothing. More recently, the F-117 was provided with the ability to replan missions in flight and to data link attack images to ground stations, as well as to drop GPS-guided weapons such as JDAM. When the plan to accelerate the retirement of the F-117 was announced in December 2005, development of further systems to prepare the F-117 for full network-centric operations was still ongoing, but was subsequently brought to a stop.
近接航空支援と対戦車攻撃専用に開発されたフェアチャイルド A10 サンダーボルト2。ユニークな外見を持つその機体は強力な打撃力と高い生存性を兼ね備えています。その A10 の破壊力の全貌をお届けします。次号もぜひお買い求めください。